Hello, we're group number 6. I'm Andres Gomez.
Ruth, Quant.
Pinto.
We're going to show our gearbox design. For our first set, we have a 22 pinion and a 62 gear set, and this one is made of steel. This one is made of cast iron. We started doing calculations with AGMA to see if it was safe to use these gears. So we came out with the bending and contact stresses. For the gear, it was 2.78, and for the pinion, 11.03, a big downfall, but all above 1, so we were good. And then for the contact, we have 3.52 for the pinion and 2.22 for the gear. And now for the bevels.
So for the second stage, we chose a 3-to-1 bevel gear set. The pinion was 15 teeth and the gear was 45. They're both made out of carburized, case-hardened steel grade 1. So we used the AGMA equations to see if we could get a good safety factor, which means that we were able to use them. So yeah, here's what we got was 1.18 for the gear for bending, 1.46 for the pinion, and for contact 1.26 for the gear and 1.18 for the pinion. And now Ruth is going to talk to you about the third stage.
For the third stage, we used, again, cast iron gears. The pinion is 80 teeth and the gear is 140 teeth with an input of 80 RPMs and an output of 45.7 RPMs for this gear set. This is to have the ultimate output of as close to 45 as possible. Using the spur gear analysis, as mentioned before, I did the bending and contact stresses for the gear and pinion. For bending, the pinion had 1.602, and for the gear, it had 1.616 of a safety factor above 1, making it good to use, as well as for the contact stress, it was 1.71 for the gear and 1.713 for the pinion. To put together our gear set, we did the shaft analysis, and mainly on the last shaft that was going to receive the most torque. The max torque that this shaft received was 2,092 pound-inches. And there was, using, again, standards and force analysis, we got the notch sensitivity to be 2.611 and a factor of safety of just below 2, making this shaft being able to withstand the max torque and the gear sets as they were put together in this next slide. This next slide has the image of our gears moving. We had minimized it so that you could see the top gears that were smaller, being able to move the larger, much slower RPM gear. The final gear, we were able to transmit the initial 720 RPMs at the first shaft and output of 45.7 RPM with the last gear. Using AGMA standards, we were able to analyze this gear set to have proper safety factors above 1 to be sure that our gears would not fail. And to put together our gear set, we went to Amazon.com after looking through the Boston gear catalog. Once we chose our gears and wrote down the particular part numbers, we searched those parts on Amazon to find the lowest prices for each of the sets. And together, the entire gearbox with all the gears was $2,827 with 11 cents. And we're able to put this gearbox design into an application such as a bore machine. This is a Prairie Dog bore machine model 900 RTW that has an 8.5 horsepower engine, just like our gearbox was transmitting 8.5 horsepower to begin with. And with these dimensions of the bore machine and the dimensions of our gearbox analysis of our gearbox, it would be able to fit, but there would need to be alterations to this application so that the gearbox and the actual machining could fit within the desired space. And that is our application to our gearbox design. Thank you.